Okay, learning something new again. We have worked with inverses before. I don't know if any of you remember the steps, but remember step 1, rewrite as y is equal. I think in this case, that's already like that. Step 2, swap the x's and the y's. Step 3, get the y by itself, so solve for y. And the very last step, when it's y is equal, you're going to put the inverse notation. Because once you get the y by itself, it's because it's the inverse. Okay, so it's already y equals. We're going to now have to swap the x's with the y. So the x goes here. Just like that. All right. So now we have a log with a base b of an argument equal to an exponent. So this is now when we have to rewrite this as, an exponential. B to the n is equal to a. So there's our base, there's our argument, there's our exponent. So 4 to the x is equal to y plus 4. Ah, fantastic. Y is outside of the parentheses. The log's not there anymore. And now we're just going to add 4 to both sides. So 4 to the x plus 4 is equal to y. And now we're going to write that with the inverse notation. All right. Now remember, if there's not parentheses, it means only the term right next to the log is the argument. Okay, so we've got our y and x. We're going to switch them place. I'm going to swap them. Well, we're going to need to get this by itself. So we'll subtract 10 both sides. When I subtract 10, we're going to put that in parentheses. So here's our base. Here's our argument. Here's our exponent. And we're going to rewrite it as b to the n is equal to a. Because remember, the inverse of logs and exponentials are inverse operations. Inverse of add is subtract. Inverse of multiply is divide. Inverse of square rooting is squaring. The inverse of logs, you rewrite it as an exponent. So our base is 2. Our exponent is x subtract 10. Our argument, wow, that was pretty easy. And then you write the inverse notation, because this is now the inverse. Okay. Ooh, now we have an exponential. The inverse of exponential is a log. And by the way, just in case any of you know, what the heck is a log? A log is a special type of exponent. So when we have log equal and the n is over here, that in English, logs are exponents. So that's the definition. All right. So we're going to swap the x and y. So y is there. We're going to subtract the 2 first. And I'm going to put this in parentheses. So the inverse of exponentials are logs. So we have to write it as log base b, the argument of a is equal to the exponent. Let's label. Let's see. Here's the exponent. Here's the base. Here's the argument. So log the base of 5, the argument, x subtract 2, is equal to y, and then we're going to put inverse notation. All right. I don't really like this a whole lot. So we're going to swap the x's and the y's. We need to get this by itself. So I'm going to think about this as it's saying -1/2 times 2 to the y. That's what this is. There's that invisible -1 there. And then we've got this divide 2 here. So if you think about it this way, we would multiply both sides by -2. So that's what we're going to do. We're going to multiply both sides by -2. So we end up with -2x is equal to 2 to the positive y. And now we can rewrite as log base b of the argument a is equal to the exponent. So we're going to name everything. Here's your base. Here's your exponent. This thing is the argument. So a base of 2, an exponent of negative. We're rewriting it as log, log base 2 of the argument, -2x, is equal to the exponent y, and then it gets the inverse notation. All right. Now we're going to talk about the laws or properties. I'm going to say it this way. Properties or rules of logarithms. Well, we're going to review laws of exponents first because they're very similar. Not logs, laws. So that's what this should say, laws of logarithms. So when you multiply powers of the same base, these are the same base. When you multiply powers of the same base, this is called the product rule. When you multiply powers, you add exponents. When you divide powers, the opposite of multiply is divide. The opposite of add is subtract. So that's called the quotient rule. When you divide powers, subtract exponents. And then lastly, when you raise a power to a power, you multiply. And that's called the power rule. When you raise a power to a power, multiply exponents. Okay, the reason why I'm saying this, that when you add logs, so let's do it this way. So this is the product rule for logs. So when you have log base b argument x plus log base b argument y, when you add logs with the same base, think about up here. When you multiply powers, you add. Here, when you add logs, you multiply the argument. I'll do it this way. So if something starts off being multiplied, when you expand it, this is how it would get expanded. You separate it into two separate logs addition. So now we're going to do the quotient rule. This is the product rule. So think about this. The opposite of adding is subtracting. The opposite of multiplying is dividing. So when you have log base b of x, subtract log base b of y, opposite of adding, subtracting, the opposite of multiplying is dividing. So that's, oops, this was supposed to have a base b there, because the same base is the point. So whichever term is first, whichever argument is first, that's what goes in the numerator. Okay, and then lastly is the power rule. Well, just like up here, when you raise a power to a power, you multiply. This is when you have a number being multiplied by a log. So here, when you have a power raised to a power, the exponents multiply. Here, when you multiply a log, we can rewrite that as that log being raised to a power. Those are some good rules, and this is called the power rule. All right, let's see that applied. So notice this is a log with a power. That's what this is. So if we work backwards, that exponent of 2 comes down in front and multiplies. So this becomes 2 log x. So that's a really easy one. So right here, you've got 2 parts of an argument multiplied. Well, that's what we have here. So if we work backwards, you separate those two into 2 separate logs. So this becomes log x. Remember that invisible, there's not a base. It means that for log log, the invisible base is 10. So this is called expanding the rules. Now, this says divide 2. Just rewrite this as 1/2. And then look at, we've got a number being multiplied. Well, we did that a second ago. We had a number being multiplied, and that number being multiplied could have been rewritten as an exponent. So that's what we're going to do here. So this is going to be, since this number is being multiplied, we can now rewrite that as log base 10 of the argument a, and that's being raised to the 1/2 power. Now, this is just the same. I didn't catch that they would be the same. All right. All right, I'm going to do a new video on this, so there's going to be a couple videos today. So this video right here is on the properties of logarithm and inverses.